In this lesson, we're going to look at the theorems that involve angles between chords and tangents and secants. So we'll start with our first one, and it says the measure of an angle formed by a tangent and a chord intersecting at the point of tangency. So here's what this picture is. Here's the tangent, and here's the chord, and we're going to find that angle measurement, the one that goes all the way between chord and tangent. That's going to be equal to 1/2 the intercepted arc. So it's like an inscribed angle. In fact, it is an inscribed angle. It just happens to be that the other point here is at the tangent point. So let's say arc AB is 80 degrees. So the intercepted arc is this guy here in blue. So we'll say that AB is equal to 80 degrees. Then what that means is angle MAB is going to be half of that. So that's going to be 40 degrees. So the angle is half the intercepted arc. So let's look at this one. It's the same thing. We have it, only this time we have a diameter and a tangent. So we know that this arc is going to be 180 degrees. So AB is 180, and that means that the measure of angle LAB has to be half that, which is 90 degrees. We should already know that because a diameter is part of a radius, and we already know that the radius and the tangent are at 90 degrees, so it all kind of ties together. Okay, our next theorem takes a little bit to write out. So I'm going to tell you first, and then you'll write it down, and then I'll show you with an example or two. The theorem is this: an angle formed by intersecting chords within a circle, so inside a circle. So we can look at this angle and this angle. That's going to be equal to half the sum of the measures of the arcs that are intercepted by the angle, or by the angles. So we'll write that down first, and then I will show you. So again, it's half the sum of the two arcs that are intercepted by the vertical angles, meaning the arcs across from each other. So the angle, which would be, let's call this guy angle 1. Angle 1 is going to be half the sum of arc AD plus BC, because you know angle 1 is going to be equal to angle 2. So it's going to be, if you have one of them, you have the other. Now, that doesn't mean that the arcs are equal, though, so be careful. The arcs are only equal if this intersection point is in the center of the circle. So don't assume the arcs are equal just because these angles are equal. That only works when it's when they are central angles. So anyway, here we go. Let's say our angle AED is going to be half of AD plus BC. So there's the theorem written out in symbols. The angle is going to be half the sum of the two arcs created. So let's say that arc AB is 50, or AD is 50, and BC is 70. That means the measure of angle AED is half their sum. So it's 1/2 the 50 plus the 70. That's 1/2 of 120. So the measure of angle AED is 60 degrees, which would also be the measure of angle BEC. It's also 60 degrees, but that does not mean the arcs are the same. So the second one, let's say OL, arc OL is 100. OL is equal to 100. And now let's have the angle. The angle MPN is going to be equal to 80. And now we want to find the other arc. We want to find arc MN. Okay, MN is not 100. You cannot assume that. So we know that 80 degrees is equal to half the sum of MN plus 100. Well, that means if you double the 80, twice the angle is equal to the sum of the arcs. So twice this angle is 160, and that equals to 100 plus MN. So that means arc MN is 60 degrees. That's how that works. Okay, so that last theorem was angles inside the circle. Now we're going to talk about angles outside the circle. So our next one says the measure of an angle formed by a tangent and a secant, or two secants, or two tangents. So looking like this, where the angle is outside the circle. It's going to be half the difference of the intercepted arcs. So inside the circle, it's half the sum. Outside of the circle, it's half the difference. So we're going to look at some three cases here. First one, an angle formed by a tangent and a secant outside of the circle. That's equal to half the difference of the intercepted arcs. So when you're dealing with the outside, you have to go in order because you are subtracting. So an angle formed by the tangent and the secant outside the circle is equal to half this quantity, the larger arc minus the smaller arc. So my next example, let's say that AC, arc AC, is equal to 140, and arc BC is equal to 60. We want to find, let's find angle ADC. So this is a tangent and a secant, so I have angle ADC. It's going to be equal to half arc AC minus arc BC. So what is not involved is this arc AB over here. We don't care about that. So the measure of angle ADC, that's going to be equal to 1/2, the larger minus the smaller, 140 minus 60. So 140 minus 60 is 80. Half of 80 is 40 degrees. So this theorem holds true for two secants too. Again, the angle formed, this angle is created by half the difference of the larger arc minus the smaller arc. So let's look at this example. Let's say that MP, arc MP, is 90 degrees. And let's see, MN this time, let's make it slightly different. MN is 140, and OP is 110. So I give you a lot of arcs, but I don't exactly give you the one that you need. And we want to find the measure of angle NQO, which is the outside angle. So here's what I have. I have MP. MP is 90. And I have MN, that's 140. And OP is 110. But I can't really use that. I need to find NO. And then take their difference. So to find NO, you have to remember the sum of all the arcs adds up to 360. So if we're going to find NO, that's going to be 360 minus the sum of the others. Hold on, I got to write that a little bit better. 360 minus the sum of those three, 90 plus 110 plus 140. So if you add them up and subtract from 360, you get 20 degrees. Now you take the difference. Now this is 20, so that angle NQO is going to be half the difference between 90 and 20. Half of 90 minus 20 is 70, so half of 70, we want angle NQO is 1/2 of 70 degrees, so it's 35 degrees. So sometimes you got to do a little bit more work to find the arcs that you need. And finally, an angle formed by two tangents intersecting outside the circle, again, is equal to half the difference of the intercepted arcs. So it's going to be the same process. It's going to be bigger minus smaller. The only difference with tangents is that two tangents pretty much cover the entire space around the circle when you talk about dividing it up into different arcs. So there's very little information you need in order to solve a problem like that, and I will show you. In a problem with two tangents, all I need to give you is one measurement and you can find the rest. So in this one, arc ADC, the major arc, is 240 degrees, and I want to find the measure of angle ABC. Well, here's why. Basically, if you're given one arc measure, you only have to find the other arc, and the entire thing has to add up to 360. So to find the minor arc, AC, you subtract the 240 from 360, and here you get 120, I think. Yep, 120. And then we can do our half the difference thing. Angle ABC is equal to 1/2 of the 240 minus the 120. 240 minus 120 is another 120, so half of that is going to be 60 degrees. In the next one, let me give you the angle 72. And I want to find the two arc measurements. Well, here's what we have to do. If I label the smaller one X, how would you label the bigger one? Well, you know that the entire thing, both these guys have to add up to 360, so this would be 360 minus X. And then you set up your equation. 72 is equal to 1/2 360 minus X, that's the major arc, minus the minor arc. So 72 is equal to 1/2 the quantity 360 minus 2x. If we double the 72, we get 144, and that's equal to 360 minus 2x. Subtract 360, and you get negative 216 is equal to negative 2x. So the minor arc is 108. The major arc would be 360 minus 108. So we will work a lot more of these in class. It's a lot of different theorems to remember, but the basic format is very similar between each one, so it shouldn't be too difficult once you practice some of these things.